This is 7th grade 6.1 lesson. In this lesson, students will be introduced to vocabulary of common solids, and they're also going to be sketching several solids. The standard covered in this lesson is 7G3. The page numbers out of the hardcover book are pages 250 through 255, and out of the practice journal, pages 137 through 140. Okay, today what we're going to be doing is, yesterday we worked with some graph paper as well as some dot paper to go through and draw three-dimensional figures. Today what we're going to do is we're going to try drawing three-dimensional figures without the use of those types of paper. So a three-dimensional figure or a solid has a length, a width, as well as a depth. So rectangles, for example, and triangles are two-dimensional figures. A three-dimensional figure is going to have that third concept. A polyhedron is a three-dimensional figure whose faces are polygons. So for example, you can see here prisms and pyramids. These would be examples of polyhedrons. They contain only polygons on every face of that figure. So polygons, once again, are going to be enclosed figures that only have straight edges. Okay, so for example, a prism has two parallel identical bases. So when they're talking about that and they say base does not always mean the very bottom. It's the shape that is consistent. Like if I were to take and cut this like a loaf of bread, it would be the shape that I would consistently get all the way through that. So there, our base would be our triangle. So notice it's not really the base, what a lot of you would refer to as the base. It's the front and the back on this, the way that it's laid on this paper right now. If I were to take it and tip it up on top of its base, then you would consider it a base. But a base is going to be that figure that goes all the way throughout that entire figure. Okay, if I were to take and cut it, I would get that same shape all the way through. Okay, so your base, here you've got two bases that are exactly the same. The lateral faces are parallelograms. So in other words, they're going to be four-sided figures. So here we actually have three rectangles that make up the lateral faces. So we've got one on that side. We also have another rectangle over here on this side, and then one that makes up the bottom. Okay, so on a triangular prism, you actually have 5 faces. So you've got your two bases, and then because a triangle has 3 sides, there are also 3 rectangles that are making up the lateral surface. So lateral surface is that middle surface between your two bases. A pyramid, on the other hand, is a polyhedron that has one base only. So notice it is only a base, and in this case, the base is a square or a rectangle. So pyramids are named according to their base shape. So here they have identified it as a rectangle, although it kind of looks like a square. This would be called a rectangular pyramid. Now, sometimes you're going to have triangular pyramids where the base is a triangle. So pyramids are named base according to their base figure. So this would be a rectangular pyramid. The lateral faces, or the faces that are coming up to that point, are all going to be triangles. So in this case, we would have 4 triangles because there are 4 sides to this base. There are 4 triangles that are needed to come up as to make that lateral face or the outside edges of that pyramid. Okay, so key thing is your base is always what is going to be used to name your prism and your pyramid. Okay, so here, yes, our base was a triangle, so this would be a triangular prism. Had this been a rectangular shape, then it would be a rectangular prism. Here, our base is a rectangle, so this would be a rectangular prism. Had it been a triangle, it would then be considered a rectangular pyramid. Had it been a triangle, then it would be a triangular pyramid, okay? So we also have some other three-dimensional figures that we will be working with throughout this chapter, and those are cylinders and cones. Okay, these are not considered polyhedrons because they have circles on them. So a cylinder is a solid that has 2 parallel or identical circular bases. So like a can, okay, you've got a circle that makes up the top of the can and a circle that makes up the bottom of the can. This middle section, known as the lateral surface area, is actually, if you were to take the label off of a soup can, that is a rectangle. So it's actually a rectangle, even though it doesn't really look like it. If you were to take the label off, you would see that that label is really a rectangle. Okay, so when we work with cylinders, it actually consists of 2 circles and a rectangle. A cone, on the other hand, is a solid that has only one circular base, and then it has a vertex or a point that it comes up to. And we'll actually be using some formulas later in this chapter to be able to go through and find the surface area as well as volume of a cone, okay? Okay, so we're gonna work on drawing some of these prisms and pyramids. We'll also kind of work on drawing cones and cylinders also within this. So the first step is when we're working with prisms, you want to draw your two bases first. And then what you're going to do is from those bases, whether it's a rectangle or a triangle, you're going to actually go through and connect your corresponding vertices. So corresponding are the same points on each of those figures. So you'll notice that here in step one, I went ahead and drew out my rectangles. And then in step two, I'm connecting the corresponding vertices. So what does that mean? It means that I'm connecting the same points on each rectangle. So notice that those are corresponding. They're the same points. I'm just connecting those together. So those are corresponding. This one, top right corner corresponds with that. Bottom right corresponds with that. And then bottom left and bottom left corresponds with this. Now, take note that you'll notice in step three that they have taken any of those hidden lines and they've made them into dashes. You don't absolutely have to do that. That's lots of times how you will see it. I will tell you I'm very bad at that because sometimes I get confused as to which ones need to be dashed. The key thing is that I want you to try drawing those three-dimensional figures. And some of you might be very good at them because maybe it's something that you've done in art before. Okay, if we were to do a triangular, let's try a triangular prism. So triangular prism, you're going to draw two triangles and offset them. So I'm going to draw a triangle, which I'm going to actually use one from up here so that it's a nice, neat triangle. Okay, so you're just going to draw your triangle the best that you can. And I'm going to make a copy of this one so that I know that they're the same. So there's my other triangle. And I'm just going to offset them. Okay, so it doesn't matter how you offset them, just offset them. And now my next step, so that was step one, was drawing identical bases. So my bases I chose for a triangle for this time. The next step is I'm going to connect corresponding vertices. So my top of my triangles, I'll go ahead and connect those. And my front edge of my triangles, I'll connect those with straight lines. And then my back edge. And this one I'm going to do as a dashed line just so that it looks neater. And it's not very straight. You could use a straight edge to do that. So there's a triangular prism. So key thing is when you're naming these, remember the bases are what are going to name the type of prism or pyramid you're working with. So here my base was my triangles, my two identical shapes. Okay, so let's go ahead and try working with some pyramids here. So I'm going to move these off to the side. Okay, when we draw a pyramid, we actually have a point, correct? So when we draw a pyramid, whether it's triangular or rectangle, we're going to draw that base first. So we're going to draw our base and then we're going to put a point up above it. Then we're going to connect each of our vertices or our corners of our shape of our base to that point. And then we can go through, if we wish, we can go ahead and change any of our hidden lines into dashed, which I told you I'm not very good at that. So here, if I were to go off, we start off with our shape of our base, and then we just put a point, and then we're going to go ahead and connect these. And you can see all of the steps are done already for me. I'm just showing you how I would do this. Okay, so I've now looked like something similar to that. And then I could go through and make dashed on those inner parts of that triangle if I wish to make it look a little more realistic. Okay, so then let's go ahead and do a rectangular pyramid. So if I were to do a rectangular pyramid, I'm going to start out with a rectangle, which I'll go ahead and use a square. A square is a rectangle. Okay, so there's my square. And I'm going to put a point somewhere up above it. And I'm now going to connect each vertice to that point. So there's that one, and then I would connect this one and this one. So this one's kind of looks like we're looking at it almost from almost above that pyramid because of how high I put that point. But you can see it does. You can see my base. I'm not the best three-dimensional drawer, but I can do a very basic drawing. And that's what I'm asking you to do is just try it out. Some of you will do a wonderful job because you're very artistic. Okay, so we're gonna go ahead and practice just drawing a triangular prism without the figures. So the key thing, start out with your triangles. And since it's a prism is where you're gonna have two of each base. So I'm gonna go ahead and draw this time. I'll draw a triangle that looks kind of like this. Okay, and I'm gonna copy that. So now I've got two triangles that are the same. You're just gonna go ahead and do yours the best that you can. The benefits of having a smart board. You can offset them however you would like. So I slightly offset them. Now I'm gonna go ahead and connect my corresponding vertices with straight lines. Okay, so there's my triangular prism. Set that off to the side. Okay, so the next one asks us to draw a hexagonal pyramid, hexagon. So a hexagon, H-E-X, the number 6 has an X. So we have a 6-sided figure. So draw the best that you can a hexagon. So hexagon, 6 sides, kind of looks like this. And if you ever have questions, you can look in the back of your book. Your hardcover book does have some samples of each of these figures. So there's a hexagon, and it's asking for a pyramid. So a pyramid has a point. So I'm just gonna go ahead and put my point here, not very far away. And then I'm gonna connect each of my vertices to that point. As straight a lines as I can. If I want it to look really good, I'd use a straight edge. Okay, so there's my hexagonal pyramid. So on that shape, I would have a base with 6 sides, which means I actually have 6 triangles coming up to meet that point. So if I were asked how many faces or surface area sides there were on there, there's actually 7 because you have your base and then your 6 triangles around the outside edge. Okay, so that's just working with some pyramids and some prisms. So now we're gonna go ahead and take a look at some cones. So for example, if I wanted to draw a cone or a cylinder, which right now they're gonna ask us to do that. So it's draw the front, side, and top views of this paper cup. Well, first of all, if I try and do it as 3-dimensional, a cone is gonna be very similar to a pyramid. So I would start out, if I was doing a cone with a circle, because that's my base, I would have a point, and then I would just take the edge of each of those sides of that circle. And I know it's not, usually when you see a cone, it does an oval instead of a circle base, because you're trying to look at it from a different view. So that's kind of how you would draw a cone. Here they're asking us to draw what it would look like if I actually just looked at it from each of these viewpoints. So the front view is a triangle. So if I were to just look at this from the front, like perfectly square on in front of me, this is really all that I'm seeing. Okay, so I would draw, it maybe looks like a triangle from the front. If you've ever gotten a snow cone and you see the cone, just the cone from one area, it looks like a triangle. The side view, that's also a triangle because the front and the side are going to look the same. And the top view, so if you looked at it, if you were eating your snow cone and you look straight down into that snow cone, what are you seeing? You're actually seeing a circle. Okay, so this is having you kind of do that visual of what would it look like from each of the different standpoints of looking at that figure. So let's try another one. So this time we've got this pyramid, and this would be a rectangular pyramid because the base is a rectangle or a square. So from the front, what would it look like? So from the front, well, I would see a triangle. So from the front, it would look like just a triangle. If I just saw it straight on and not from an angle, I would just see a triangle from the front. So this is my front view. My side view, well, if I turned and I looked at it from the side, I would see once again a triangle. So here's a side view. So I would see a triangle from the side. And this is the next one is the one that's always very tricky, is looking at a triangle, or not a triangle, but a pyramid from the top. What you're really going to see is that base, because remember, it spreads out going to that base. So when you look at it from the top, you're actually seeing from the top, you're seeing what that base would look like. So it looks like maybe a square or a rectangle. You might see that very point like right in the middle, but you're actually seeing the base shape when you look at it from the top view. Okay, so let's try another one. How about a triangular prism? So this is a prism. How do I know it's a prism? Because it's got two triangle bases. Okay, pyramid only has one base that goes to a point, and a prism has two bases that are the same. So if I looked at that from the front, so I'm saying that this is the front right here, I would see a triangle. Now somebody else might say the side's the front, but I'm going to identify the front, that base, as my front. If I looked at it from the side, what am I seeing from the side? Well, if I turn this around, I'm seeing this blue figure from the side. I'm seeing a rectangle. So my side view would be a rectangle. And from the top, if I looked at that down from the top, I would actually be seeing this bottom shape with a line maybe cutting through the middle of it, because I would see that this edge cutting through the middle. So I would see another rectangle. And if you want to get really, detailed, you could say, yes, I'm seeing another ridge going across here, because that's the very point of your prism there. Okay, so let's try one more. Once again, this is just having you break down shapes and look at them in a different manner. So this time I have a cylinder. So what would it look like from the front? Well, from the front, right now, if I'm looking at it from the front, I'm seeing kind of a rectangle. Slightly curved, but for the most part, it's a rectangle that I see. Maybe curved a little bit on the top and the bottom, but it's still a rectangle. If you were to take a can and put it off in the distance and just see it straight on line view, it would look like a rectangle. Okay, although you know it's a can and you know it's a cylinder, you would see it as a rectangle. Okay, from the side, I would see the exact same thing. I would see that rectangle. And from the top, if I look at a can from the top, I would see a circle. Okay, so once again, that's it for this lesson. It's just having you work a lot with using your visual skills to create those three-dimensional figures, to break down those three-dimensional figures and see what they would look like as two-dimensional figures. So the key thing to get out of this lesson, make sure that you understand the difference between a prism versus a pyramid. So a prism is going to have two bases that are the same. So prism, this would be an example of a prism where you've got two bases that are opposite of each other. So I've got two triangles, okay, that are then connected by other faces, but I have two bases that are the same. A pyramid, on the other hand, is going to have one base and it's going to come to a point. So this would be an example of a rectangular pyramid because it has a rectangle on the bottom and it comes to a point up here up at the top. Okay, your shapes are going to be named according to their base shape. So this is a triangular prism, okay, because it has a triangle as a base. If we had a rectangle as the base shape, then it would be a rectangular prism. You could also have really any shape of your base. So whatever the shape of the base is, you would just say that and then prism behind it. So like if I had, and I'm not good at drawing something like this, but I'll try my best. If I had a hexagonal prism, I would have another hexagon that looked just like this back here. Like I said, I'm not good at drawing on these. And then I would connect each of these points, to their corresponding. So this would be known as a hexagonal prism, okay? If it was a hexagonal pyramid like we did earlier, I don't know if it's still there, it comes to a point. So it's got a hexagon on the bottom and then it comes to a point. So that's a pyramid. Prism, two bases, pyramid, one base. Okay, then your cylinders and cones are both consist of circles as their bases. A cylinder has two bases and a cone comes to a point. So that's pretty much it for this lesson. Good luck and just keep trying your best. I'm not expecting perfection out of this, but just that you try and break down those shapes.